Bismillahirrahmanirrahim. Assalamualaikum and very good morning to our believer lecturer of subject Power Electronic, which is Sir Saifuzam. Today, our group, which is me Muhammad Hassanuddin bin Alias, Muhammad Lutfi Hadi bin Azmi and Muhammad Rasyidi bin A.Rahim, we will present to you our mini project, which is uh, boost converter. So without wasting any time, we will proceed to next slide. In this presentation, we will talk about introduction, operation, calculation, and result of a boost converter. Introduction. One of the simplest switch mode converter type is a boost converter. It takes an input voltage and exchange or leave it as name implies. Everything is content is an inductor, a semiconductor which is a MOSFET this day, and this day you can find a really good one, a diode and a capacitor. There are only a few parts required to make a boost converter. As you can see, it's a less cumbersome than inductor or AC transformer. They are so simple because they were originally created to power the electronic system on the aircraft in 1960. The need for this converter to be as compact and as effective as possible was a requirement. The greatest benefit offered by boost converter is their high efficiency. Some of the which can even go up to 99%. Wow. In other words, 99% of the input energy is transformed into useful output energy, and only 1% is wasted. Interesting.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Azmi. Today I'm going to present about the operation of boost converter. So firstly, how the boost converter works is we store some energy in the inductor from the input and transfer that same energy to the output at a high voltage. This happens many thousands of times a second depending on the oscillator frequency. And so the energy add up in every cycle. So you get a nice measurable useful energy output, for example 10 joules every second. As the equation tells us, the energy stored in the inductor is proportional to the inductance and also to the square of the peak current. To increase output power, our first step might be to increase the size of the inductor. This will help, but not much as we think. If we make the inductance larger, the maximum peak current that can be achieved in a given time decrease, or the time taken to reach that current increase. So the overall output energy does not increase by a significant amount. However, since energy is proportional to the square of the maximum current, increasing the current will lead to a larger increase in input energy. So here we can understand that choosing the inductor is a fine balance between inductance and peak current. Next, we move to the final details point on how the boost converter operation. The first one is the oscillator. You can keep the MOSFET output switch on forever. No inductor is ideal. They have saturation current. If we did keep the MOSFET switch on for any longer than a few hundred microsecond max, the supply will be short circuit and the inductor insulation burn off. when the MOSFET goes burst and other nasty things happen. The second one is the MOSFET itself. During step 3, the MOSFET sees a voltage that is the supply voltage plus the inductor voltage, which means that the MOSFET has to be rated for a high voltage, which again implies a rather high on resistance. Boost converter design is always a compromise between MOSFET breakdown voltage and on resistance. The switching MOSFET of the boost converter is always the weak point. And the third one is the inductor. Just any old inductor won't work. Inductor used in boost converter should be able to withstand the high currents and have highly permeable core or porous core, so that the inductance for a given size is high. That's all for me. Bismillahirrahmanirrahim.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Rasyidi bin A.Rahim di 0111101006. For this slide, I will present the specific frequency and duty cycle that we choose. We choose the frequency at 40 kHz and duty cycle 0.4. For this slide, this is the circuit of DC-DC boost converter generator that we made from the MATLAB Simulink. This slide show the result for inductor current and voltage from resistor. This is the duty cycle pulse from the output voltage graph. This slide show the output voltage of resistor and current of inductor. We get the maximum output voltage is 82.50 and minimum 82.22. For the minimum current of inductor, we get the minimum is 2.198 and the maximum is 3.653. This slide show the calculation part for this circuit. The output voltage we get 83.33 volt. The inductor current we get 2.778 ampere. The maximum current we get 2.843 ampere and the minimum current we get 2.155 ampere and the output voltage ripple we get 0.1667 volt. And the lastly is result overall. The result from simulation, the VO we get 82.47. The I max we get 3.654 ampere and I min 2.198 ampere. The result from calculation, VO we get 83.33 volt. The I max 2.843 ampere and I min 2.155 ampere. Okay, that's all. Thank you.